I'm attending the 17th annual Acute Leukemias meeting at Munich, and it's been a very interesting meeting, and I've been giving a talk about some mechanistic aspects of epigenetics in acute myeloid leukemia and talking about epigenetic therapies in acute leukemia. There are a number of emerging epigenetic therapies, and it's becoming apparent that they seem to be only modestly active as single agents. The most impressive of these so far, and they've been the subject of a few talks since we've been here, have been the inhibitors of isocitrate dehydrogenase isoforms 1 and 2. These are mutated with neomorphic mutations in around about 20% of acute myeloid leukemias, and they are in general associated with a relatively poor prognosis. So inhibitors have been developed to block the neomorphic enzymatic activity of these enzymes, which prevents them from generating the oncometabolite 2-hydroxyglutarate. There are two of these that are currently in usage. One of them has been registered by the FDA, enasidenib, which is an inhibitor of IDH2, and there is also ivosidenib, which is an inhibitor of IDH1. They're showing very good results in relapsed refractory setting with overall response rates of around about 40%, which is very good for a targeted therapy as monotherapy. Unfortunately, they are associated with persistence of the disease. They tend to cause differentiation rather than immediate cell death, and some of the presentations at the conference have been focusing on the mechanisms of resistance, which are interesting in themselves. There are some genetic abnormalities that co-occur with IDH mutations which appear to confer a degree of resistance, and there are mutations which will be acquired and confer resistance, and these are predominantly in signaling molecules such as RAS mutations. It's also possible that IDH proteins themselves can be mutated, and you can switch from having an IDH2 mutation and pick up an IDH1 mutation, which would not be targeted by the specific therapeutic, again as a means of generating resistance. So it's obvious that we need to think about them in combination with other therapies, and some of the talks have also focused on how that might come about. So that is something for the future, but in general these are good agents, very promising, but as always we don't know quite how to deploy them, so that will be the future work to keep us going over the next couple of years.